Bright Tuty. Every student matters.
First question is prove that root 5 is irrational. So we will do it really fast because we have done such questions in the examples. So let's assume root 5 is rational. Now based on this assumption we can write root 5 into p by q form, where q is not equal to 0. P and q are co-primes. So p and q are such integers which are co-prime to each other, right? Now this is our assumption. So squaring both sides, I'll get p square by q square equal to 5. So which further will give me p square equal to 5q square. Now I can see 5 is a factor of p square, right? So 5 divides p square, or if you want to write it like this, 5 divides p square. You can write it like this also. Hence I can say 5 divides p. Why? Based on that theorem that we did in the introduction. So if 5 divides p, so we can assume p in form of 5m, right? 5 is a factor of p and m is any other integer, okay? So 5m, right? So now we will put p equal to 5m. Let us say this is equation 1. Put p equal to 5m in 1, okay? So this will give me 5m square equal to 5q square. So this will give me 25m square equal to 5q square. Hence 5m square equal to q square. Now you see 5 is a factor of q square. Hence here I can say, based on this, 5 divides q square. So 5 divides q. Now 5 divides p and 5 also divides q. Hence 5 is a factor of, 5 is a common factor of p and q, right? So which contradicts our original assumption that p and q are co-primes, right? Our assumption was that p and q cannot have a common factor, but with this assumption we reached at a conclusion that 5 is common factor of p and q, right? So our assumption itself is wrong. Our assumption is wrong, right? So we can say root 5 is irrational, okay? This is how we will do these proofs. Now this is a combination, right? 3 plus 2 root 5. We need to prove this as irrational. We will still prove it by contradiction, but now we will use our knowledge that root 5 is irrational. While doing this question, we already know that root 5 is irrational, okay? And this is a fact. So let's assume 3 plus 2 root 5 is rational. So based on this assumption we can write this equal to p by q, where q is not equal to 0. P and q are integers. P and q are integers co-prime to each other. Integers co-prime to each other, right? So this is our assumption. Now in the next step what we can say is 2 root 5 is equal to p by q minus 3, right? So this is equal to p minus 3q by q, right? And in the next step root 5 is equal to p minus 3q divided by 2q. Now look at the left hand side. Left hand side we have got root 5 which is irrational. This is what we know already. Now look at the right hand side. In the right hand side we have got p minus 3q, which is an integer, because p and q are integers. So we have just, let us say you have got 3 and 2. Okay, if you do 3 minus 3 into 2, what will be the result? Result will be minus 3, which is still an integer. Okay, so p minus 3q is an integer and it is being divided by 2q. Q is non-zero, so 2q is also non-zero. Hence, the right hand side is a rational number. So which suggests that root 5 is also rational. But we know already that root 5 is irrational. Okay, so which contradicts this is a wrong result. Hence, our assumption itself was wrong. Hence, our assumption was wrong, and 3 plus 2 root 5 is irrational number, right? Because irrational number cannot be equal to irrational number, right? So this is a wrong result or wrong conclusion. Okay, hence we can say we started with a wrong assumption. Okay, so what is wrong in this question? Every step is right, so the assumption itself was wrong. Okay, so we can say 3 plus 2 root 5 is irrational. Now we need to prove that the following are irrationals. So again, let's assume them to be rational. So 1 by root 2 equal to p by q, where q is not equal to 0. P and q are co-prime integers, right? Now look at this equation. If you multiply and divide the left hand side by root 2, okay, it won't change the equation. This was our assumed equation, okay, because we assumed that 1 by root 2 is rational. So now you see the numerator is root 2 and the denominator is 2. So it is equal to p by q, right? Based on this we got this result. Now we can say root 2 is equal to 2p upon q. Okay, p and q are integers, so 2p and q are also integers. If p is an integer, 2p also will also be an integer, and q is non-zero. So this right hand side is written in p by q form, okay, which is rational. But we know that root 2 is irrational. Now the statement that you will make is 2p by q is rational. Hence root 2 is rational. But this is wrong conclusion, as we know that root 2 is irrational. Hence we can say our assumption was wrong and 1 by root 2 is irrational. Okay, so this is what you will write after this. All right, let's move to the next one here. Now we need to prove 7 root 5 as irrational. So let me do these questions really fast now that you are comfortable with the concept. Okay, so the steps are same. Let's assume 7 root 5 as rational. So we can write it in p by q form, where you will always write that q is not equal to 0, because then it will be not defined. Okay, and p and q are integers co-prime to each other. Okay, this is what you will assume. Then you can write root 5 as equal to p by 7q. Now you just need to explain that q is non-zero, so 7q is non-zero. Hence this number on the right hand side is rational, because it is also written in p by something form, where the something that is in the denominator is non-zero. So this number on the right hand side, p by 7q, is rational. So it is suggesting us that root 5 is also rational. But this conclusion is wrong. And why did we arrive at the wrong conclusion? Because our assumption itself was wrong. So our assumption was wrong. Hence you can say that 7 root 5 is irrational. 7 root 5 is irrational. Okay, I hope this is clear to you. Let's move to the next one here, which is 6 plus root 2. 6 plus root 2, again we will assume, let's assume 6 plus root 2 is rational, right? So it can be written in P by Q form, where Q is not equal to 0. P and Q are integers. Okay, all right. So root 2 is equal to P by Q minus 6. So I can write P minus 6Q by Q, right? Now P and Q are integers, so P minus 6Q is also an integer. Q is also an integer which is also non-zero. So the right hand side satisfies the condition for it to be a rational number. So this is a rational number, which suggests that root 2 is also a rational number. But we know that root 2 is irrational, hence the wrong conclusion, hence our assumption was wrong, and we can say that 6 plus root 2 is irrational. So these are the statements that you will write here, and you will say that by contradiction, here the contradiction is there because a rational is equal to irrational, right? So we can say 6 plus root 2 is irrational. Okay, so this is how we will do questions in this exercise. Okay, now we will meet in the next exercise, where we will talk about terminating and non-terminating decimal expansions of irrational numbers. Okay, thank you.